Okay, so we continue with exercise 3C. So I'll continue with question number 6, questions related to simple harmonic motion. So in the previous part, I gave you all the rules that you require in order to do the simple harmonic motion question. So now we will continue to use these equations and try to make ourselves familiar with these equations. Okay. They say here a particle P is moving in a straight line with simple harmonic motion. The center of the oscillation is O and the period is pi over 2 seconds. When OP is 1.2 meters, okay, the P has speed 1.5 meters per second. Find the amplitude of the motion. Now, do you see what's going on here? You know, in SHM, you have a yeah, this is centered around, okay, so you have the center O, okay, so it's oscillating about the center O. The period is given to you, T equal, the periodic time is pi over 2 seconds. When OP is 1.2 meters, so OP, so there's a point called P. So when OP is 1.2 meters, they're saying, so basically when X is 1.2 meters, the speed, the V value is 1.5 meters per second. They're asking you to find the amplitude of the motion. So which of these equations are you going to use in order to find the amplitude? So which of the equations are you going to use? If you're trying to, of course, get the, since the speed is given, you can see V is given, you can go for V square equal omega square, A square minus X square. So V is known, X is known, amplitude I should find, but you can see omega. Now, you know here, V and X are the variables, omega and A are constant. So omega constant, we do not know it yet. How do we find this omega constant? What equation are we going to use? So that's why we have the period is given over here. Period is pi over 2. So T is 2 pi over omega. So periodic time is pi over 2 equal to pi over omega. So pi cancels out. You can see here omega equals to 2 times 2, 4, right? Omega is equal to 4. Okay, and then using V square equal omega square, A square minus X square. So we will use here V is 1.5. Omega is 4. Amplitude is what we are trying to find. X is 1.2. Okay, so 1.5 square divided by 4 square equal to A square minus 1.2 square. Do you agree? So 1.5 square over 4 square is actually 16 plus 1.2 square equal A square. Can I have the answer here? A equal, that is the root, right? So if you want to get the A value, you have to take the square root of this whole thing, isn't it? So A would be equal to the square root of this entire thing. So A equals, it goes on, right? It's, I think this is not a finite answer. So you get 1 point. Get me the full answer. We get here. So you get here 1.257229096. It goes on. So basically you can give your A here to 3SF 1.26 meters corrected to 3SF. So this is the amplitude. Okay, so this is the amplitude, basically the maximum displacement. And then they say part B, at time simple t seconds, the displacement of P from O is x meters. When t equals 0, P is passing through O. Can you see at time t seconds, the displacement of P from O is x meters. When t equals 0, P is passing through O. Find an expression for x in terms of t. Okay, so how do we do this? Part B. So we use the equation. Obviously, you know, we're trying to get an expression for the displacement. So for displacement, we use x equals, which equation is it best to use? And you know, there are two equations, x equal a sine omega t and x equal a cos omega t. Which one is the best one to use? So when you're having, you know, you're starting the simple harmonic motion from the center of oscillation. Therefore, you must use x equals a sine omega t. So this is the equation to be used if you start the oscillation from the center. So x is equal to, they're asking us to get the expression for x. So x is, we leave the variable. A is the amplitude, which you found 1.26. Sine omega is a constant, which is 4. So sine 40. So this is the answer. X equal 1.26 sine 40. So this is the expression for x in terms of t. Okay, so next I'll go to question number 8. They say a particle P is moving on a straight line with simple harmonic motion between 2 points A and B. The midpoint of AB is O. Okay, can you see? So basically when they say the particle is moving on a simple harmonic motion between the 2 points A and B and the midpoint of AB is O means, what do you realize immediately about A and B? A and B are the two corners and those are the places where you have the two amplitudes on either side of O. So when OP is 0.6 meters, the speed of P is 3 meters per second. Okay. So let's mark this. So over here you have O. You have O. So particle P, so this is end A and B. So when OP is equal to 0.6 meters, okay, so if OP is equal to 0.6 meters, basically when X is 0.6 meters, the speed is 3 meters per second. And when OP is 0.2 meters, the speed is 6 meters per second. I think you know what you should do here. Now, when they ask you to find the distance AB, basically you have to find what? AB is twice the amplitude. Because AB is, you need to realize O to B, O to A is the amplitude. So AB distance is twice the amplitude. All you have to do is to what? Find the value of A, amplitude. And just multiply it by 2 and you get the AB length. Okay. Okay, so all you have to do here is to now create two equations. So in this case, you can see to get amplitude. So mainly we use the equation V square equal omega square A square minus X square. But you can see over here that we do not know A and we are trying to find A and we also don't know omega. So that's why they've given you two sets of unknowns. Okay, so let's apply. V square equal omega square A square minus X square. V square equals 3 square, omega square is unknown, A square minus X square is 0.6 square. Agreed? V square equal omega square, A square minus X square. So V is 6. Omega square, A square minus X is 0.2 square. Do you agree? So now you have two equations. Can you see? I have made two equations with these two sets of data. And now what do? We have to solve these two equations simultaneously and try to get the value of A. So what's the best thing to do here? The best thing to do here is to divide. So equation 1 divide by equation 2. Three square over 6 square equal omega square A square minus 0.6 square over omega square A square minus 0.2 square. So when you simplify, you can clearly see when you divide, the omega square cancels. That's the whole reason behind dividing, right? The whole reason, that's the reason that we divide, in order that the omega square cancels out and you can get an equation and only in terms of A. So 3 square over 6 square, we can actually make it into a simpler value, right? How much is it? 3 square over 6 square. So 3 square is 9 over 36, which is 1 over 4. 1 over 4 equal a square minus 0.6 square over a square minus 0.2 square. All you need to do is to solve this equation, make a the subject. 4 times a square minus 0.04, right? How much is 4 times 0.6 square? Let's multiply 4 into 0.6 square. So this is 1.44. So now it's a matter of making a the subject. So minus 1.44 comes here as plus 1.44 minus 0.04 equals 4a square minus a square. Guys, do you agree? 1.44 minus 0.04 is 1.4. 4a square minus a square is 3a square, which means a square is 1.4 divided by 3, which is 7 over 15 equal a square. So a is root 7 over 15. So what's the value? Simplified third. So root 7 over 15, which becomes root 105 over 15. And you can make it into 3 dp, which is 0.683. 0.683 meters, correct? 3 SF. Okay, but is this actually what we require? It's not the amplitude they ask. They ask us to get the distance AB. So AB distance is, 2 times the amplitude. So actually it's better that we multiply with the exact term so that we have the full decimal, which is, so when you multiply it with 2, you get 2 root 105 over 15, which when you make it to 3SF, you get 1.36626, it goes on. So 1.37 meters, correct to 3 significant figures. Okay, so this is the answer. Part B, they are asking you to get the period of the motion. How do you get the period of the motion? So period of the motion is equal to pi over omega. Are we aware of the omega value yet? No, but we did find the value of A. So we can use the value of A on any one of these two equations and get the value of omega. So let's get it. So I'll use equation number 1, 3 square equal omega square, A square minus 0.6 square. So I prefer to go in exact as much as possible. 3 square is 9 equal omega square. A square is, how much is A square? 1.4 over 3, or A square is 7 over 15. A square is 7 over 15 minus 0.6 square is 0.36. Agreed? Okay, so it's a matter of making omega square the subject. Omega square is 9 over 7 over 15 minus 0.36. How much is the answer? So root it, square root it, and you get the answer. How much is it? 15 root 6 over 4 when you make it to 3 dp or to 3SF. 9.18, it goes on, right? 9.187, isn't it? It goes on. 9.185, sorry. 9.1855, it goes on. Okay. All right. And then we are supposed to get the periodic time. So periodic time is what they want us to find. 2 pi over omega. Input the value 2 pi over omega is 15 root 6 over 4. Guys, do you agree? So 2 pi over omega, get the answer, and we get 0.68402. It goes on. So the answer is 0.684 seconds. Okay, so this is the answer. Okay, so we'll move to question number 11. They say a mark boy is moving in a vertical line with simple harmonic motion. The boy rises and falls through a distance of 0.8 meters and takes 2 seconds for each complete oscillation. Calculate the maximum speed of the boy. So you realize that if it is moving with simple harmonic motion, okay, and if it's moving with SHM, and they say it rises and falls through a distance of 0.8 meters. So rises and fall. Obviously, you know, the marker buoy is something that floats in the water. So this is the water level as it rises and falls. The buoy rises and falls. So it rises and falls through a distance of 0.8 meters. So what does this mean? And since it's going with SHM, it means the center is going to be in the middle. So it's at the midpoint of this 0.8 meters. The 0.8 meter is the complete height difference between the water level. Do you agree? So it's the complete height difference, which means the center of the SHM, the center of your simple harmonic motion will be in the middle of 0.8. And what else can we directly know? And then 0.4 meter will become the 0.4 meters will become the amplitude. Okay, because you know these two endpoints, you know the center of the SHM is over here in the middle, which means if the whole distance is 0.8, amplitude is the distance from the center over to the two corners. So then you know that will be 0.4 meters. So immediately we know in the question amplitude is 0.4 meters. Time taken is 2 seconds. The periodic time, capital T, not just T. And they say the capital T is 2 seconds. Calculate the maximum speed of the buoy. How do we find the maximum speed? Where does the maximum speed occur? So you know the rules of SHM. We explained this in the previous part. Maximum speed always occurs at which point in SHM? Maximum speed occurs at the Vmax occurs at where? Vmax occurs at when x is 0. Vmax occurs when x is 0. Okay. All right. So then let's use the equation v square equal omega square a square minus x square. So v square is what I'm trying to find. Omega square. Do we know omega? We need to find omega, isn't it? Because we're trying to find the Vmax. We need to find omega. How do we find omega? That's why they have given you the periodic time. So periodic time is 2 pi over omega. T is 2 equals to 2 pi over omega. The 2 cancels and you get omega equals to pi. You get here omega equals to pi. Do you agree? So omega will be equal to this is pi square. Amplitude is 0.4 square minus x is gonna be 0 because you have the center. Vmax occurs when x is 0. Okay, so v square equal pi square into 0.4 square. So when you remove the square root, so we removing the square root from everyone, it's 0.4 pi, which gives me how much? It's 0.45, which is 1.256637061. Yeah, 1.2566. It goes on. Okay, so then you can leave this answer to 3SF, 1.26 meters per second. Answer correct to 3SF. Okay. Part B, they're asking you the time taken for the buoy to fall a distance 0.6 meters from its highest point. So which means the highest point means at the very top. Okay. So from the highest point, the time taken to fall 0.6 meters. So basically falling 0.6 meters down. Okay. So one thing you need to realize here is that if you start from the top over here and you're going down, you need to realize that you're going to what? You're going to pass the center, right? Do you see that you are going to pass the center? Now, you know, normally x is measured away from the, we measure it from the amplitude. So our particle is over here. So we measure and you can see here, this particle, it passes the amplitude and goes to the other side. Do you see? It passes the amplitude and goes the distance of how much to the other side? 0.2 meters. Do you agree? It passes a distance of 0.2 meters to the other side. Okay. So let me show you 2 ways. Now they're asking us to get the time taken for the buoy to fall this 0.6 meters. Okay. So we know the amplitude is 0.4. So it falls the amplitude plus another 0.2 meters. And we are supposed to find the time taken to come from here to here. So how do we find this time? Okay, so there are two ways. I'll show you two ways of doing it. The first method is a slightly longer way, and I'll show you a short way. First, we'll do the longer way. The longer way is, if you recall, do you remember me telling you in the first section about the periodic time and how to divide the periodic time? Do you recall me telling you that we can divide the SHM motion into 4 equal parts? The time taken to go from the amplitude to the center to the amplitude, and then again back from the amplitude to center and center to amplitude. Do you recall that it's all what? So if I show you, I think we wrote this down, right? I think, do you see this diagram? Do you see what's happening here? From the center to the amplitude, what's the time taken? Capital T over 4. Can you see? The time taken to go from the center to the amplitude will be a quarter of the periodic time. Do you get it? It's a quarter of the periodic time. It's T divided by 4. So which means now you need to realize you are also coming from the, we are starting from the amplitude at the very top. And we come to the center, which means the time taken to come from here to here will be capital T over 4. Great. That's capital T over 4. And this time taken here, this, okay. So this time I have to find it separate, this particular time. So first, how do I find the time taken to move 0.2 meters from the center? How do we, which equation are we going to use to find the time taken to move 0.2 meters from the center? Can we actually divide the capital T any further? I have told you, you can't divide capital T any further than this. Okay. So to the time taken to move 0.2 meter from the center, which equation are we going to use? X equals, do you recall the equations and how they work? X equals A sine omega t. Because you learned if the particle starts at the beginning, now at time zero in the sense, the place where you actually consider as the beginning. So if you're starting from the center, the time taken to move is found by using X equals A sine omega t. That's extremely important. So over here, I'm taking the time taken to come from the amplitude to center by using a quarter of the periodic time. And the time taken to come from O to this point, we can find that by using, so let's say this time is T1. I'll find T1 by using what? X equals A sine omega t. So let's use it. X is 0.2 meters. Amplitude is 0.4. Sine omega is pi times T1. Now you can see I can easily find what? The value of T1. So it's half sine pi times T1. Can I know how much is sine inverse half? Sine inverse half is pi over 6 equals pi times T1. So T1 is 1 over 6. So you see T1 is 1 over 6. Okay, so that's the time to move 0.2 meters from the center. But that's not the only thing. I have to find the time also taken to come from the amplitude to the center, which is T over 4. So total time taken is equal to, it's equal to capital T divided by 4 plus 1 over 6. So capital T, do we know the periodic time? Yeah, it's 2 seconds. Capital T is 2 seconds. So 2 over 4 plus 1 over 6. Half plus 1 over 6 is 2 over 4 is half, right? Half plus 1 over 6, what is the answer? Two over 3 seconds. So 2 over 3. So this is the total time taken, or in other words, the time taken for the boy to fall a distance 0.6 meters from its highest point. I hope all of you understood. In this case, I found the time under 2 sections. Okay, I didn't get the time immediately. I found the time under 2 sections, considering always the fact that the amplitude to center is a quarter of the periodic time. And from the center, I measure the time by using X equal A sine omega t. So this is the first method, the longer method. This is the first method. Let me also show you a shorter method. So let me show you there's another way of getting this time. Let's see that. Okay, so we'll go to the next method where we can actually find the time in one step. Okay, so how do we find the time in actually one step? Do you recall that there is another equation that we use to measure the time? If you are starting from the endpoint in the sense the amplitude. It shouldn't be anywhere else but the amplitude. So you can see here in this case, our particle starts from the amplitude. Do you see? So whenever you have the object starting from the amplitude, the time taken can be measured by using x equals a cos omega t. That's the rule, isn't it? So that's the rule. If p is at the end point, or in other words, the amplitude of the oscillation, when time is 0, we can use x equal a cos omega t to model how this is moving, the movement. So how do we work with this? Now, what is the x value? You do realize x is the distance that it moves from the center. X is not measured from the amplitude. It's not measured from the end point. X is measured from the center. So if x is measured from the center, what is the x value here? So when you fall 0.6 meters below the amplitude, what is your x value? What is the x value here? X value, can we use x as 0.6? No, x is measured from where? The definition of x is measured from the center. So in this case, x value is how much? You can see it has fallen. When you measure from the center, it's 0.2. It's 0.2, but you can see that it has passed the amplitude and gone to the other side, right? So where in such a situation where the particle has passed the amplitude, passed the center, now it starts from the amplitude, it has passed the center and it has gone over to the other side. In such situation, the x value should be minus 0.2. A positive x value would mean that you are over here. You are that means you have not passed the center yet. A positive x figure would mean that you have not passed the center yet, but a negative x figure in the sense because you are passing the center. So you see now, x is measured from O. X is measured from O. Your particle started the motion from the end point. So from the end point, let's say you moved over here, say you moved 0.1 meters. So if from the end point, if you moved 0.1 meters, the x value is 0.3. You use x as 0.3 here. Okay, and then you can get the time taken to move this distance, the 0.1 meter distance. But you need to realize now the problem here is our particle is not within this sphere, it's not within this part. It has passed the center and gone to the other side. So in this case, if you use x equals 0.2, okay, the equation, what you will actually do here is you will the equation will consider the object is over here and take this as 0.2. Do you get what I'm saying? So if you want the equation, if you need this to realize that you have passed the amplitude, that you have passed the center, and gone to the other side, you must use x as minus 0.2. Okay, otherwise if you use plus 0.2, the object will be considered up to this point. Okay, and you'll get the time taken to come from here to here. Okay, so here x will be minus 0.2. That's really important. Amplitude is 0.4 cos omega t. So omega is pi t. Do you agree? So minus 0.2 equals 0.4 cos pi t. Okay, so minus 0.2 divided by 0.4 equals to cos pi t. Okay, so how much is the answer? This is minus half equals cos pi t. Cos inverse of minus half. Cos inverse of minus half is in radian mode. Cos inverse of minus half gives you 2 over 3 pi equals pi t. And t will be, the pi cancels out and you get 2 over 3 seconds. So you can see I got the same time. Using 2 different methods. In this method, we do the longer way. This is the longer way. This is the shorter way. Okay, so you need to understand how to, when you're using method 2, you have to be really cautious. You need to understand when to use x as plus and when to use x as minus. Remember, if you're using method 2, from when you start from the, it's really important that when you start from the amplitude, okay, the minus sign, it's you need to understand when you're using x equal a cos omega t, when to put the minus and when not to put the minus. That is really important. So once again, I'll remind you just to give you a quick brief. So when you are using x equal a cos omega t, number one, you know x equal a cos omega t is used only when you start the motion from the end point. And from the end point at the same side, on the same side, that means if you have not passed the O, if you haven't passed O, say you have come over here, maybe you have traveled, let's say 0.3 meters. So if you have traveled 0.3 meters, what's the x value you use? The x value you will use here will be 0.1. So remember, now you can see I'm using plus 0.1 here. Can you see? Plus 0.1 equals amplitude 0.4 cos omega is pi t. So if you use this, the t value you get here, this t value, or let's say it's t2, this t1 value, I'll mark it as t1. The t1 value you get here will be the time taken to move this 0.3 meters from here to here. That's the time that you will get. What happens if you use x is minus 0.1? When you use x equal a cos omega t, and if you use x as minus 0.1, what will the equation understand? What will it perform? How will this equation perform? When you use x as minus 0.1, the equation understands that this is what a displacement not above the origin, not on the side of the, or not on the side of the, I mean, now you had the object on this side, let's say the top side. Now here your object is at the top. So when you use x as minus 0.1, the equation realizes that it's not that, the 0.1 is not above the O, it's not above the center, but it's going to be below the center. Below the center, away from the amplitude that you started. So that's how it works. So the minus sign, it's really important. So a plus sign, a plus x figure would mean that you are above O on the same side as the amplitude. A minus x figure would mean you're on the other side of that amplitude, not on the same side. You're on the other side of the center. Okay. So that's how you actually correctly use this equation. I hope you guys were able to understand the significance of the negative sign. Okay, so it's not used all the time at the necessary place. You must use it in the places where it is necessary. Okay. Question number 14. A particle P is moving along the x-axis. At time t seconds, the displacement x meters of P from the origin O is given by x equals 3 sine 4t plus half. Now you can see here, this is again another model. You see again another model. You can see here, normally we discuss two main models that describe the displacement with respect to time. That was, one was x equals a sine omega t. The other model was x equal a cos omega t. So this is normally x equal a sine omega t is used if the particle starts the movement from the center, from O. X equal a cos omega t is used if your particle starts its motion from the end point, from the amplitude. But you can see this obeys none of them. And then what does this look like? I think you can see, remember that there was a third model which we rarely use. What was that? If P is at some other point, when P is 0, use x equals a sine omega t plus alpha. Can you see that we actually have this a sine omega t plus alpha here? Do you see? So if you're starting at some other point, so you can see actually we have x equals a sine omega t plus alpha. I think that's the format that we're dealing with here. Okay. So just to give you a heads up, a sine omega t plus alpha. Okay. So then in part A, they ask us to prove that the particle is moving with simple harmonic motion. So how do we prove that a particle moves with SHM? So there's a key signature here when it comes to SHM. What is it? Regarding the movement, there is one really important aspect. The acceleration is always towards the center, and the acceleration is directly proportional to the displacement. So thereby, if an object, if the acceleration obeys the format minus omega square x, that means the particle will move in SHM. If any object has an acceleration function that looks like this, if any object has an acceleration function that looks like this, it will move in SHM. Okay, so all you have to do is The x equation is given. You need to create what? You need to create the x double dot. How do we create the x double dot? So we differentiate first once and we get the velocity x dot. So differentiate once, what do we get? 3 into sine differentiation is? Sine differentiation is cos. Cos 4t plus half. Is that all? Sine differentiation is cos into 4t differentiation is 4. Chain rule. You need to keep differentiating. Do you agree? Okay, so x dot will give you 4 into 3, that's 12. Cos 4t plus half. Do you agree? And then let's go for x double dot. So x double dot is 12 times. What's the differentiation of cos? Cos differentiation is minus sine. Cos differentiation is minus sine. 4t plus half. Are we done with only 4t plus half? No, here keep differentiating 4t plus half. The differentiation is 4. Do you agree? So x double dot equal, what's the answer? Can you simplify? Minus 48 sine 4t plus half. Okay. And then, did I come into the format yet? Now, you know, x double dot is supposed to give a format of x double dot equal minus omega square x, right? So where is the x term here? I don't see an x term. X double dot needs to be a negative constant with x. So where is it? How do we get the x back into this equation? We have a big function of sine 40 plus half. So what do we do with it? If you recall, I think you can see at the top here that 3 sine 40 plus half is actually x. 3 sine 40 plus half is actually x. Do you agree with me? I could break the 48 as what? 48 as, when you divide by 3, 16 times 3 is 48, right? Do you agree? 16 times 3 is 48. So x double dot. So minus 16 and 3 sine 40 plus half is what? 3 sine 40 plus half is x. So you can see here, I have got an equation of the format x double dot equal minus omega square x. So this means what? So you can immediately say this, therefore particle moves in. Therefore particle moves in SHN. Okay, so we are done with part A. Moving on to part B, right now on the amplitude and period of the motion. So obviously, what's the amplitude? Do we need to find it? Is there anything that we need to find here? I mean, do we need to perform any calculation? No, it's not necessary to perform a calculation because the amplitude is x equal a sine omega t plus alpha. A is 3. A is equal to 3. Okay, and then omega. So omega will be, as you can see here, x double dot equal minus omega square. So from here also you can see omega square is 16 and omega is 4. Or you can see it from here. X equal a sine omega t plus alpha. Here also you can see omega is 4. So you can get omega from any one of those two places. So omega is 4. Okay, so they ask us to get the amplitude and the periodic time. So periodic time is 2 pi over omega, which is 2 pi over 4. So periodic time is pi over 2. Okay. Part C. Calculate the value of x when t is 0. How do you find the value of x when t is 0? Just use t as 0, right? So when t is 0, x equals 3 sine 4 into 0 plus half. So we get here x equals 3 times sine half. So remember, you need to type sine half in the cal, not sine inverse half. So what is sine half? What's the answer you get here? X equals 3 times sine half, and the answer is 1.44. Remember, calculator should be in the radian mode. Okay, this is to 3 SF. 1.44 meters, correct to 3 SF. All right. Part C. Okay, then moving on to part D. Moving on to part D, they say calculate the value of T. For the first time, P passes through O. So when you first pass through O, what's happening? When you pass through O, your X value will be, when you pass through O, the X value will be 0, isn't it? So you know the particle at time 0, you saw clearly the particle at time 0 was your particle at the origin. No, right? It was 1.44 meters away from the origin. Do you agree with me? So they are asking you to find the time taken when the path of the particle to first pass through O. So first passing through O means you set X to 0 and input the equation X 0 equals 3 sine 40 plus half. Guys, are you with me? Remove the 3 to the other side. 0 divided by 3, that's 0 equals sine 40 plus half. 0 divided by 3 is 0. Sine 40 plus half. And then you can get here sine inverse 0. Equals to 40 plus half. Sine inverse 0. So what are the possibilities that you could get here? Sine inverse of 0 is 0. You get pi, you get 2 pi, it goes on. There are so many angles, but we need to take the first angle that is positive, isn't it? They want the first time because they're asking the first time. So there are many times that you can possibly get, but we want the first time that gives us a positive figure 40. So you can see if I use 0, plus half will go to this side as minus half. 0 minus half is minus half. Can time become a negative figure? No. So you realize 0 is out. Because time cannot be negative. So therefore, the next answer I go with is pi. So we'll go with pi because I only want one answer. 40 plus half equals to pi, which means 40 equals to pi minus half. So t equals to pi over 4 minus 1 over 8. Pi over 4 minus 1 over 8. Do you agree? So therefore, this is in decimals, it becomes 0. It goes on 660 to 3 SF. 660 seconds. Okay. Okay, so next we'll move to question number 15. They say on a certain day, low tide in a harbor is at 10 a.m. and the depth of the water is 5 meters. So at low tide, the depth is 5 meters. High tide on the same day is at 4:15 p.m. and the water is then 15 meters deep. Let's quickly draw a sketch to understand what's going on here. So I drew a vertical line here to represent the height. Okay, so this is, let's say this is the seabed. Okay, so low tide. Okay, low tide occurs at 10 a.m. And at low tide, what's the height? At low tide, the height is 5 meters. And then they say high tide on the same day. So high tide means the water level has risen. High tide on the same day is at 4:15 p.m. The water is then 15 meters deep. So over here at this point, this the complete length from the seabed, this length is 15 meters. A ship which needs a depth of water of 7 meters needs to enter the harbor. So there is a ship, it needs at least 7 meters of height of water in order to enter the harbor. Assuming that the water can be modeled as rising and falling with SHM. Okay, so if the water is rising and falling with SHM, do you see how the water levels rise and fall? The water level doesn't go down to 0, right? It oscillates between where and where? It oscillates between 5 meters and 15. It oscillates between 5 and 15. It oscillates between high tide and low tide. High tide and low tide. Do you get it? It oscillates between high tide and low tide. So which means what? So if it is oscillating the high tide and low tide points, these 2 points are the 2 corners, which means the center is over here, exactly in the middle. So I think you can see high tide, low tide. What's the height difference? High tide, low tide, the height difference is 10 meters. Do you agree? The height difference is 10 meters, which means the amplitude is going to be, you do see that the height difference is 10 meters, right? The height difference is 10 meters and the amplitude will be 5 meters. Okay, so the amplitude is 5 meters. And then what about the periodic time? Guys, the periodic time is the time taken to perform one complete oscillation. So over here, a complete oscillation would be if you start at low tide, but you go to high tide and you come back to low tide, isn't it? So it has to be like you need to come back to where you actually started. So what will be the periodic time? You can see from low tide to high tide, you start at 10 a.m. and you end up at 4:15 p.m. So that's how many hours? 4 hours to 10 a.m. to 4:15 p.m. How many hours? 10 a.m. 6 hours and 15 minutes. That's 6 hours and 15 minutes. That's one way. Are we done with that? Do we have the periodic time yet? No. So periodic time means when you do the complete round, which means the high tide has to come back to low tide, which will take another 6 hours and 15 minutes. So altogether, the periodic time will be in hours. Periodic time will be 12.5 hours. So this is really important that you understand these. First thing is to understand the amplitude and the periodic time. Okay, now the question is, they say there's a ship and it needs a depth of water. It needs 7 meters. So basically, if it needs 7 meters, can you see it needs, the water level needs to reach 7 meters in order for this ship to enter the harbor. Assuming that the water can be modeled as rising and falling, they say calculate the earliest time to the nearest minute after 10 a.m. at which the ship can enter the harbor. Okay, so now in this case, at time 0, you need to realize time 0 is what we consider as what? At time 0 is the ship at the center or at the amplitude. You know, at time 0 is what we consider as 10 a.m. now. At 10 a.m. we are at the amplitude, the low tide mark. So then the water level needs to rise 2 meters. So if you're at the low tide mark, if you're at the amplitude, what equation are we going to use to calculate time? If you are at the amplitude when time is 0, what equation are you going to use to get the time? We use x equals a cos omega t. We use x equals a cos omega t. Do you agree? And then what is the x value? Now you can see you have risen 2 meters up, right? And have you passed, by any chance, have you passed the center and gone to the other side? No, right? You're on the same side as the amplitude yet. So how much is the x value? Yeah, how much is the x value? The x value is, are we going to use 2 meters? No, you know x is measured from the center. So if this is displacing 2 meters here, the x distance will be, guys, the x distance will be 3. So 3 equals amplitude is 5 cos omega t. Do you agree with me? And what about the omega value? So omega needs to be found. We know the periodic time. T equal 2 pi over omega. T is 12.5 equal 2 pi over omega. So omega equals 2 pi over 12.5. So can I know the value? 2 pi over 12.5 is 4 over 25 pi. Agreed? Okay, and then shall we substitute the value? 3 over 5 equals cos omega t. So omega is 4 pi over 25 times t. Guys, shall we go for cos inverse? What is cos inverse 3 over 5 in radian mode? In radian mode, what is cos inverse 3 over 5? So basically, wait, let me make T the subject. Let's get the answer. T equals the 25 will come to the top, 4 pi will come down into cos inverse 3 over 5. Guys, can you see what I did over here? 25 came to the other side as a multiplication, 4 pi came as a division. So 25 over 4 pi into cos inverse 3 over 5. This is the time. Type the whole thing in the cal and you will get the time taken in hours because our omega is in hours. Okay, since our omega is over here, we've done the periodic time in hours. Okay. It's in rads per hours, omega will be. So in that case, T will be, your time will come in hours, which is 1.844795. It goes on like this. This is many hours. So now what you need to do is this time, they want the time, right? At the time at which the ship can enter the harbor, which means you have to give the time after 10 a.m. So we know time 0 is what we consider as low tide at 10 a.m. time 0. So after 10 a.m. So what is the time? 1.844795 hours later. Do you agree with me? So 1.844 means you have one complete hour. Do you agree? There is one complete hour, which means from 10 a.m. we actually go to 11 a.m. And there's another how much of an hour? Another 0.844795 of an hour, not a complete hour. So you have another part of an hour, almost, because it's 0.8 of an hour. So this will convert to minutes because we don't have a complete hour here. A complete hour is 1 hour. So here you have a complete hour and 0.844795 of an hour, which means this section you will multiply it with 60. We'll take this in minutes. So how much is it? You have here the time taken is 1 hour and can I know the answer? 0.844795 into 60, it is 50 point. Get the answer. So which is 50.6877. It goes on. So basically, how many minutes? Nearly 1 hour and we can say 51 minutes because it's 50.6. So 1 hour and 51 minutes. So 1 hour and 51 minutes after 10 a.m. The time which the ship can enter the harbor is 11:51 a.m. Okay. So this is the time which the ship can enter the harbor. The first time that in which the ship can enter the harbor. Okay, so in part B, they asked to find the time by which the ship must leave. So what do you mean the ship must leave? Now you know the ship can enter the harbor after 11:51 a.m. So 11:51 a.m. after 11:51 a.m. you know the water continues to rise until 4:15 p.m. And then after 4:15 p.m. the water again starts to fall. It will again start to fall and there will come a time when the water will reach a depth of 7 meters over here. So that's the ship must leave before that time. So that's what they ask, the time by which the ship must leave. So basically you have to find the time taken for the water level to drop back to 7 meters again. Okay, so there are many ways of doing this. Okay. One way is actually, now you know you reach high tide at 4:15 p.m. right? So first I'll say the longer way, then I'll say the shorter way so that you have many ideas in your head when it comes to the exam. So I'll say the longer way first. In the longer way, you know at 4:15 p.m. you are at the very top. Do you agree? Then you know you want to find the time that you come back to 7 meters. So which means now you can consider the motion from 4:15 p.m. You can consider the motion starting at 4:15 p.m. and at 4:15 p.m. you are at the amplitude. So if you are at the amplitude, what equation are we going to use? We can use x equals. We can use the equation x equals a cos omega t. Do you agree? And in this case, because you are passing the center and going to the other side, the x value you are using must be a positive x figure or a negative x figure. You are passing the center and going to the other side. The x value you use must be negative. So how much is it? It's negative 3 because you can see you reach a 7 meter depth when you are 3 meters away from the center. Guys, do you agree? 3 meters away from the center. Isn't it? You can't use 2. X is measured from the center. 2 meter is this distance. This is the 2 meter. You cannot use X as 2 meters because X is always measured only from the center. When you use X equal A cos omega t. And this time your X is a negative value. Why? I told you previously, I explained you. If you start at the amplitude and you pass the center and go to the other side, in such situations, the X value should be negative. If you don't pass the center, then X is positive. Got it? So minus 3 equals amplitude is 5 cos omega t. Omega is 4 over 25 pi t. Now this is actually the longer way. Okay. This is the longer way of doing the sum. I'll show you a shorter method soon. So this is just to give you more ideas and more options when it comes to the exam. Guys, are you with me? So your time is, this is cos inverse minus 3 over 5 equals 4 pi over 25 times t. So t equals 25 over 4 pi into cos inverse minus 3 over 5. So guys, what's the time value? You'll get the time in hours. Can I know the time value? 25 over 4 pi into cos inverse minus 3 over 5. Show me. Yeah, what's the answer? We get here 4.40520. It goes on. Okay, so this many hours. So what do you do now? You measure the time from which point? You measure the time from high tide at 4:15 p.m. So 4:15 p.m., 4 hours and 0.40520 hours later, the object, the water level is down to 7 meters. Do you agree? So how many hours and minutes? So you have here 4 hours and 0.40520 hours. You should multiply by 60 to make it into minutes. So when you multiply that by 60 to make it into minutes, you get what do we get here? This is 24.312, which means it's nearly 24 minutes. So basically, now remember again, it's important that you remember where you measure this time from. You took X equal A cos omega t, which means that you measure the time from the amplitude, the high tide. In this case, we took the high tide. And then we passed the center and went to the other side. That's why we used X as negative. And then we get 4 hours and 24 minutes later, we are at the 7 meter depth, which means what? You had to add this time to the time at the amplitude, which is the high tide. So which is 4:15 p.m. So 4:15 p.m. plus 4 hours is how many hours? 4:15 plus 4 hours is 8. 8 hours and 15 minutes plus 24 minutes. 15 minutes. So 4:15 is 4 hours. I mean 4 p.m. and 15 minutes. So if you add 4 hours and 24 minutes later, it will be 8:39 p.m. So guys, the ship should leave before. The ship must leave. Ship must leave before. Ship must leave by, or you can say it's not before. We can say the ship must leave by 8:39 p.m. Guys, do you understand? So this is the longer way of doing the sum actually. Okay, you can use the calculation and this is the longer way of doing the sum. There is actually another quite short way of doing this sum. So what is the shorter way of doing the sum? Let me show it to you. Part B. Okay, so the shorter way of doing this sum is like this. Now you do realize that simple harmonic motion is actually also there's one important thing. This motion is actually symmetric. Symmetric in the sense, now you took how many hours to go from the depth 5 meter to 7 meter? To travel from the depth 5 meter to 7 meter, we took 1 hour and 51 minutes. Is that correct? We took 1 hour and 51 minutes to go from a depth of 5 meter to 7 meter, which means you need to realize also when you're coming back to reach back from 7 to 5 also, you will take 1 hour and 51 minutes. So it's symmetric. You get me? So which means now you know the periodic time is how many hours? The periodic time is 12.5 hours, which means the time taken to go this whole journey. And then from this whole journey, there were 12.5 hours. If you subtract this 1 hour and 51 minutes, do you see that you get the time with which the ship must leave? The whole journey, the whole tide is 12.5 hours. So you know this time, the 7 to 5 meter gap, the water level takes only 1 hour and 51 minutes. So subtract the 1 hour and 51 minutes from the periodic time. So what do you get here? 12.5 minus. So we'll subtract the decimal figure 1.844795. How much is it? 12.5 minus 1.844795 is, subtract the two values, and then we'll get the time taken to go from the low tide to the 7 meter point. How much is it? 1.844795. And that is 10.655. It goes on. 655205. It goes on. So now remember, you are measuring the time from the low tide now. Okay, because we took the periodic time 12.5 hours and we subtract the time taken between 7 and 5. So then now you get the time difference, 10 hours and how many minutes? You have 10 hours and 0.6552 hours, which you should multiply by 60 to make it into minutes. So you have 10 hours. And then when you multiply with 60, you get 39.3123, which means 39, the nearest minute is 39 minutes. Guys, are you with me? So then how do we get the time? 10 hours plus 39 minutes later. From low tide, you reach the place where the ship must leave again. So which means what? When you add to 10 a.m., you have to add the 10 hours and 39 minutes. So what do you get? 10 a.m. plus another 10 hours. So that is 8 p.m., isn't it? Or 20. So 10 plus 10 is 20. 20 hours, 39, 20, 39. Or in other words, 20 means 8:39 p.m. So can you see I'm getting the same answer by using completely two different approaches? So both approaches are fine. Okay, so you need to do one of these two methods to get the answer. So it's important that you realize that the SHM is symmetric. Okay, so I hope you understand this part of the lesson really well now. Okay, so we'll move to question number 16. Points A, O, and B lie in that order in a straight line. Okay, so there is an order. A is first, O second, B at the end. A, O, B lie in that order in a straight line. A particle P is moving on the line with simple harmonic motion with center O. They're saying there's a particle P, it is moving on the line with simple harmonic motion with center O. The period of the motion is 4 seconds. I think immediately from the period you can find the omega value, isn't it? That's why they give you the period. And the amplitude is 0.75. Now, by any chance, is it correct for you to assume that A and B are the two endpoints? Can we just simply assume A and B are the endpoints? Because over here they don't say the particle is oscillating between A and B. If they say the particle oscillates between A and B, then yes, A and B are endpoints. But over here, they don't mention anything like that. They have given you the amplitude separately. And there are 2 points called A and B. O is the center. And they have said, can you see OA is 0.4 and AB is 0.9. Guys, you need to mark this on a diagram. So we'll draw this on a horizontal line, right? So it doesn't matter which way you draw. I'll draw it on a horizontal line. O is the center. O is the center. O is the center. Okay, O is the center. And then point A. Now they say A, O, B lie in that order, right? Which means A has to be somewhere over here, O and then B. So they say distance OA is 0.4. So O to A distance is 0.4 meters. Guys, are you with me? We know the amplitude is 0.75, right? Amplitude is 0.75 and the distance AB is 0.9. So AB in the sense B should be somewhere over here. Do you agree? So AB is 0.9 means what's the OB distance? If AB is 0.9, it means the OB distance is, guys, OB distance should be 0.5. Do you agree? Because if AB is 0.9, so since we know A to O is 0.4 and we know it lies in this order, OB should be 0.5. Do you agree? Okay. Okay, so they're asking you calculate the time taken by P to move directly from B to A. So direct movement from B to A, what is exactly the time taken? How do we find the time taken directly from B to A? So you can see B and A is not at the center. It's not at the end points. So it's somewhere in between. How do we find the time taken to move from B to A? How do we find the time taken to move from B to A? So what we need to do, can we use x equal A cos omega t? X equal A cos omega t can only and only be used if you're starting the motion from the end point or from the amplitude. So over here, the motion does not start from the end point, starts at a random some point called B. It's in between. You cannot use x equal A cos omega t. That's really important. So even x equal A sin omega t. How do we, I mean, like, can we use that? Now the thing is, you're moving from B to O. So I did tell you simple harmonic motion is symmetric, isn't it? If it is symmetric, what do you understand? I want the time taken to move from B to O, right? The time taken to move from B to O will be what? Will be the same as the time taken to go from O to B. So if I ask you the time taken to move from O to B, are you able to give me the answer? How do we find the time taken from O to B? You can use x equals which equation? The time taken to go from O to B, you can find it from by using x equal A sin omega t. So the time taken to go from O to B would be the same as the time taken to come from B to O. Do you agree? And also, what about the time taken to go from O to A? Can't we find that as well? We can again use what? X equals A sin omega t. So basically, it's using x equal A sin omega t twice. And you get the time taken to move directly from B to A. That's all you need to do here. So we'll get the O to B time. X equals A sin omega t. Okay, O to B, B to O are the same. So X is 0.5, amplitude is 0.75 into sin omega t. Actually, omega should be found, right? T equal 2 pi over omega. Periodic time was given as 4 seconds equals 2 pi over omega, which means omega equals 2 pi over 4, which is pi over 2. So 0.5 over 0.75 equals sine pi over 2 into t. What do we get here? 0.5 over 0.75 is simplified answer. 0.5 over 0.75 is 8 over 15. So we get here sine inverse 8 over 15 equals pi over 2 into t. And therefore we get t equals, sorry, 0.5 over 0.75 is 2 over 3, right? Yeah, sorry. This is 2 over 3. So we get here the answer sine inverse 2 over 3. So then we'll move the pi over 2 to the other side. It becomes as 2 over pi. So 2 over pi into sine inverse 3 over 5. So this is the time taken. I'll say it's T1, time taken to go from O to B. Similarly, you should also find the time taken to go from O to A. Are you with me? So again, we will use x equals A sine omega t. So x is 0.4, amplitude is 0.75, sine omega is 5 over 2 into time. 0.4 over 0.75 sine pi over 2 into t. 0.4 over 0.75 is 8 over 15. Sine pi over 2 into t. So it's going to be sine inverse 8 over 15. Pi over 2 into t2. Let's put it as t2. So t2 is 2 over pi into sine inverse 2 over pi into sine inverse 8 over 15. Okay, so then the time taken to move directly from A to B. So A to B time taken will be T1 plus T2, which is 2 over pi into sine inverse 3 over 5. Plus you add it with the other time, right? T2, which is 2 over pi into sine inverse 8 over 15. So this is the exact figure. You need to type this in the calc and get the answer. The answer is 0.822. It goes on, right? 0.82. Sorry, this is sine inverse 2 over 3, right? So I'm just doing a careless error here. This is 2 over 3. Guys, can you see? Sine inverse 2 over 3, right? So this error over here. Okay, so then you get, so we get over here, the figure will be 0.8226807. It goes on. So correct to 3SF. The answer will be 0.823 seconds.